Hello everyone. The topic of today's video lecture is row Echleon form. So what is meant by row Echleon form of a matrix? So a matrix A is said to be is said to be in row Echleon form. Said to be in row Echleon form. If it has following properties. If it has following properties. So first of all, any row consisting entirely of 0, any row consisting of all 0 elements, right, which we called as what? A 0 row. Any row which contains all elements as 0, that is 0 row, occurs at the bottom of the matrix, must occur at the bottom of the matrix. So this is the first condition. Then what is the second condition? If a row is non-zero row, means at least one element is non-zero. If a row is non-zero, that is consisting entirely of not a 0 element, then the first non-zero entry of that row is 1, and which we called as a leading one, right? So if any row is non-zero, then its first non-zero entry must be a 1, which is called leading one. Then third condition is for two successive non-zero rows, the leading one in the higher row is further to the left. Then the leading one in the lower row. What does it mean? It means if we have two rows, both are non-zero rows. So one in the higher row must be on the left hand side of the one in the lower row. This is the meaning of the statement. So let's see some example. In short, if I'll be asked, check whether a given matrix is a row Echleon form or not. So what I'll do, I'll first check whether it's a upper triangular matrix or not. Right? Upper triangular matrix. After that, make sure that all 0 rows must be in the bottom. Then look for non-zero entry in each non-zero rows. And all entry in the non-zero rows must have all elements below it as a 0. Then non-zero entry in that particular row, the first non-zero entry must be a 1. So these are the points that one has to check if we want a row Echleon form. So let us see. For example, if a matrix is given 1, 2, -1, 4. Then next what we have? 0, 1, 0, 3. Then next I have 0, 0, 1 and minus 2. Right? So first of all, what I'll check whether it's a upper triangular matrix or not. Yes, it's upper triangular matrix. Now, do it have any non-zero rows? Yes, it has 3 non-zero rows. Does it have any 0 rows? No 0 rows. So no question of 0 rows in the bottom. Again, see the first non-zero entry in the first row. So this is 1, which is a 1. Then in the second row also first non-zero entry is 1. So my leading one also, here also leading one. Again check. Now if these are the two successive rows, so leading one in the upper row is to the left of leading one in the lower row, right? So if I'll compare these two, if I'll compare these two rows, right? So again which one is the higher row? So higher row is this one, this is a lower row. So leading one in the higher row is to the left of leading one in the lower row. So all the conditions are satisfied. So this is a row Echleon form. Okay, now let us see another example. Say if I'll have the elements as 1, 2, minus 3, 4. Then what it is? 0, 2, 1, minus 1. Then what I have next? 0, 0, 1, minus 3. Is it a row Echleon form? So first check whether it's upper triangular matrix or not. So yes, it's upper triangular matrix. Then next go for, does it has any 0 rows? No, it does not have any 0 rows. So no question of checking whether it lies in the bottom of the matrix or not. Okay. Then next, all rows are non-zero rows. So just check whether first leading non-zero element is 1 or not. So what we find here, first non-zero element is this, which is 1. Whereas in this, the leading element is 2. Whereas it is required to be what? 1. So that's why this is not a row Echleon form. Because of this, because leading one in the second row is not 1. It's 2 here. The question is, can we make it as a row Echleon form? Yes, if I'll divide second row by 2, so this will become a row Echleon form. So like this one has to check. So I hope the concept is clear to all. Now in the next video lecture, we shall see the matrix associated or the subspace associated with the matrices, that is row space, column space and null space. With this, I am ending the video. Thank you one and all.